So this is the third in the series where we're going to be doing the standard cost variances. So hopefully you've tried this and you already have a solution and you're just comparing to what I have. So for the material price variance, we want the actual price times the actual quantity purchased. And so in this case, we don't have to multiply it out because it's already been multiplied out. Then for the middle term, we want the standard price times the actual quantity. So they actually purchased 850 and they should have paid $6 a pound. So then the absolute value of the difference is the variance, and in this case it's unfavorable. Now for the quantity variance, we want the pounds used times the $6 allowed, or standard price, and then the standard price times the quantity allowed, the standard quantity allowed for the feet produced. So we produced 700,000. We were allowed to use 1.19 for each one, and the price should have been $6. And then we take the absolute value of the difference, and in this case that is favorable. All right, so hopefully that went well for you. Let's now move to labor. All right, so we actually paid that. We didn't have to do the math. Actual price of the labor hours incurred was that. And then the actual hours times the standard price. So we incurred that many hours and we should have paid $27 an hour for those. And so then the absolute value of the difference, and that is unfavorable because the actual is higher, actual price higher than the standard price. All right, and then how much labor should we have used given how many feet we produced? We should have used that much labor, 0.09 hours, at $27 per hour. And so then the absolute value of the difference is our variance, and it is also unfavorable because the actual hours are higher than the standard hours. And then for the variable overhead variances, so we have what was spent, and then for the middle term, that the variable overhead is spread based on labor hours. All right, and so the middle term would be the actual labor hours times the variable overhead rate per hour. And so your spending variance, in this case it's favorable. And then here we need the hours allowed for the output produced times the variable overhead rate. And then the absolute value of the difference, and this is unfavorable. Okay, now fixed overhead is a little bit different. This is what was spent, and then the question is, what was the static budget at the beginning of the year? So at the beginning of the year, they thought they were going to make that many feet, and so that should have used that much in labor and that much in fixed overhead. And so we have a small fixed overhead variance, and that is unfavorable because the actual is higher. Now for volume variance, we would have, this is based on direct labor hours. So for the 700 feet, we would have had that much in labor hours times that fixed overhead rate. And so we're going to have a favorable volume variance because the volume was higher. Actual volume was higher than what was budgeted. They have 700 feet, budgeted 690. So I forgot to mention that about the story. They were going to buy some materials that they wouldn't have as much waste, and the labor wouldn't have to redo the seals. So let's look at our variances and interpret them and see whether or not the new materials seem to be reducing waste and reducing labor. That was the hope, that they were going to pay more for them, but it was going to offset some very unfavorable variances that they were experiencing. So let's look. So they did in fact pay more, $255,000 more than standard for the materials. That's not a surprise. What we want to see is that they were able to get rid of the big unfavorable variances in waste and labor. All right, so what about waste? We do have a favorable material quantity in waste. So that's great. There was a lot less thrown out than standard. So that does look like it is having an effect. It's not as large an effect as the 255. So just economically, just on the basis of this, it might not be justified. But if all this waste made labor inefficient, then now that there is so much less waste than standard, did that inefficiency go away? And we look down here at labor, and labor is still inefficient. So the reason that they were taking so long was not that they were dealing with scrap. It must be something else, because we took care of the scrap. There's far less scrap, than even a lot less than what standard would permit. And so whatever they're spending time on, it wasn't just the seal. And so this seal is probably not enough to justify. I don't know what the unfavorable variances used to be. So maybe the delta or the shift would be enough to justify the 255. But the labor did not stop being inefficient because they're not having to redo the seal. So there was some other explanation for the labor variance. All right. That's it for today.